points so far. So between B and C, the variation, so we'll see, find out at C VB2 plus change in shear, change in load. So that would be 40 multiplied by 3, and this will be negative load. So minus 120, so minus 48. At C, we have minus 48. But again, you would see that moving this one, one thing has happened, that it has crossed, it has changed sign. So we somehow we need to find out this point as well. We'll find out that point later. And then between C and D, we just have to focus on the load. This is the moment, so this is not the load. So this would be computed in the bending moment diagram, but not in the load diagrams. So as far as the load is concerned, we will see there is no load between C and D. So the load is computed as 0. So we have another point of minus 48. Then at E, we have plus 48. So we computed at 0, and this came out to be 0. So very simple points: minus 60, minus 60, 72, minus 48, minus 48, minus 48, and 0. Because the load between C to E was just 0 load. No extra load was there, so we just have to this. Once we have all these points, next point is to connect those points looking at the load diagram. No load variation, 0 load variation would mean 0 slope. So between these 2 points, 0 slope. Between B and C, constant load. Constant load would mean constant slope. So we connected it with the straight line. And then between C to E is a constant 0 slope, so constant 0 slope between it. So much easier. Again, we need to find out this point, and for this, this has been done. We need to find out how much far this total distance between B and C is 3. So we assume this distance is x. So x over 72. So that means x over 72 equals to 3 minus x over 48. Similar triangles. This triangle and this triangle. This side is x. This side is 3 minus x. This side is 72. This side is 48. So x over 72 equals to 3 minus x over 48. So just find out x was equal to 1.8. This was important because we have to compute at least one moment at this point as well. So looking at the moments, we have moments of A, that is 0. Then B would be 0 plus the area of this shape, that's minus 1, minus 60 multiplied by this distance was 1. Between A and B, the distance is 1, so this area will be minus 60. When you compute this one, then the x. I think there's nothing difficult in this one, so you can find out all these values. MB is minus 60. Similarly, MX will be MB, the minus 60 plus the area of this triangle. So the 1 over 2 multiplied by 72 multiplied by 1.8, this came out to 4.8. So we had so far points 0, minus 60, and then point at x was 4.8. So you were just drawing points, 1, 2, 3 points. Fourth point would be computed at D, just like previous moment plus the area of this triangle. We computed this one, and then this was easy because this is just a rectangle, so we can compute. So we computed points minus 24, minus 72, and we had a reaction. There was a couple added into it, so couple would come in this situation. It's a clockwise couple, and that is positive. Again, while we are computing moments, there was an extra moment already applied to this beam. That was a clockwise moment, so it is positive. And while we were computing moments at D, we just added that thing as well. Just like we have extra point loads here, we always add it. Similarly, if there is an extra moment, we just add it in the situation. So we added this one, we computed all the areas. So we had points 0, minus 64.8, minus 24, minus 72, then 48 because of the extra added moment, and then the 0. The next point comes how to correct these values. Constant shear straight line. And between this point, continuous decreasing load, constant decreasing shear between point B and X.